Now this question just says determine the period of each function. We are, again, for all of these, going to graph them to get used to graphing. So for part A, we want to graph y equals cos of 6x, and then after we graph it, we're going to say what the period is. What will that 6 do? What kind of transformation? Horizontal or vertical? Is it inside or outside of the function? It's horizontal. It's inside the function. It's inside of cos. So that 6 is going to affect your x values. What are you going to do to your x values? It's going to be a compression, right? We're going to multiply our x values by 1/6. So if we think about our normal cos graph, if we compress it by 1/6, it's only going to affect the x values. So our y values aren't going to get changed, and we can right away put our maximum and our minimum on our graph. It's going to go from -1 to 1. Now usually we marked one period here, and we marked it as 2 pi and divided it into 4 equal sections. But because we're compressing it, what's going to be one full period now?
Pi over 3.
It's going to be pi over 3 or 2 pi over 6. So you can think of it, if I took my regular period, which was 2 pi, and I multiplied it by 1/6, that could be 2 pi over 1. And you can leave it as 2 pi over 6, or if you want, you can simplify it as pi over 3. And what we always do in sort of developing our shortcut for graphing sine and cos is once you've marked one period, you then go and divide it into 4 equal sections. And sometimes I find that students find it difficult to label those sections, so this is the way that I do it that I find the easiest. I've got pi over 3. The next easy one is half of pi over 3. If you took pi over 3 and multiplied it by half, that would just multiply your denominator by 2. This is going to be pi over 6, right? Because that's just cutting it in half. And this first ticky mark would be cutting it in half again. So this is going to be pi over 12. Now, as far as figuring out the third one, once you figure out the first one, each of these are equally spaced. So does it make sense that if this is 1 pi over 12, this is 2 pi over 12, this would be 3 pi over 12, and you could write it as 3 pi over 12, or you could simplify that to pi over 4. So again, when figuring these out, we find our period first. It's easy to cut it in half. It's easy to cut it in half again, and then you can count by pi over 12s in this case to find out the third one is 3 pi over 12 or pi over 4. So now if we were to graph this, this is a cos graph. Where does cos start? At a maximum. So you start at your maximum, and then at each of your 4 sections, it goes maximum to middle to minimum to middle to maximum. And we have our graph. And off to the side here, we can now say the period is 2 pi over 6 or pi over 3. The reason I like to write it as 2 pi over 6 is the 2 pi over 6 really shows that we compressed our original period of 2 pi by a factor of 1/6. The simplified one is not wrong. But again, you don't lose marks for not simplifying in grade 12. And in fact, I find the 2 pi over 6 has more meaning than the pi over 3 in this case, because it says my original period was 2 pi, and I multiplied it by 1/6. For the second one, y equals tan of 2/3 x. The tan graphs are always a little bit more difficult. When graphing your tan graphs, first of all, this is a horizontal stretch. Does it make sense that you're going to multiply x by 3/2? So when graphing your tan graphs, your tan graphs have asymptotes. And those are the easiest things to start with. We had, normally, this one here was at x equals pi over 2, your first non-permissible value on your axes family. If you took x equals pi over 2 and multiplied it, because it's affecting your x values, by 3/2, can you see that you would get 3 pi over 4? So all I did was I took that asymptote was at pi over 2, and I did the stretch by multiplying it by 3/2, and I got 3 pi over 4. Similarly, this one, which was negative pi over 2, will be negative 3 pi over 4. This one that was at 3 pi over 2, if I multiply it by 3 over 2, I will get 9 pi over 4. Once you have your asymptotes, the next key points on your tan graph were 0. If you multiply 0 by 3 over 2, you still get 0. This next point was at pi, but if you would multiply pi by 3 over 2, you would now have 3 pi over 2. And having those asymptotes and having those x-intercepts labeled is enough. You can now draw your curve like your x-cubed graphs. And we've got our graph of tan. Looking at our graph, what's one full period? Well, one full period would be going from one asymptote to another, because that's how often that x-cubed picture repeats itself. How far is it from negative 3 pi over 4 to 3 pi over 4? Or how far is it from 3 pi over 4 to 9 pi over 4? 6 pi over 4. So we can figure out the period by looking at our new graph. We can also figure out our period by thinking, what is the original period of tan? Tan's original period is 1 pi. And if you took that 1 pi period and stretched it by 3 over 2, you can also see that you would get 3 pi over 2. Because we have a horizontal stretch. Our original period was pi. We multiplied it by 3 over 2. Now our period becomes 3 pi over 2. And our last example, sine of x over 7. First of all, when you're dividing, you could always write that as a fraction in front if that helps you see what you're multiplying by. Here, the x value is multiplied by 1/7. This will be a horizontal stretch. You'll multiply your x values by 7. And so when we go to graph sine, again, it doesn't affect the y values. So you're going from -1 to 1. And when I mark one full period here, what will one full period be? 14 pi. Because it was normally 2 pi, and we've stretched it by 7. And so 14 pi divided into 4 equal sections. What's half of 14? What's half of 7? You could write 3.5, or you could write 7 pi over 2. Now if you count, if this is 7 pi over 2, if you count 3 in this direction, 7 pi over 2, 14 pi over 2, 21 pi over 2, or 10.5 pi. Where does sine start? In the middle. In the middle going up, so it'll start here, go to your maximum, back to your middle, down to your minimum, back to your middle. And there we have our graph. Now at the bottom of your page, they've got a shaded box which has a couple of formulas in it. These formulas are not on your formula sheet. That's not the one I'm looking for. There it is. Period of a trigonomic function. What we're going to do here is we're going to just rewrite them so that you pay attention to them a little bit more. And I'm going to use a capital B. For both sine and cos, if you have a value inside, which is a horizontal stretch or compression, then the following formulas are true. Your period is always going to be 2 pi, because that's what you started with, divided by whatever your B value is. Which makes sense, because if B is 3, can you see that that would be a horizontal compression by 1/3? And so you would multiply 2 pi by 1/3, which is the same as dividing by 3. And rearranging this formula, because sometimes we'll have a graph and we'll want to write the equation, I can rearrange this formula for solving for B, multiply both sides by B, divide both sides by the period, and your B value is always 2 pi divided by your period. So for sine and cos, this is the formula because your initial period is 2 pi. For tan, the formula is a little bit different because your initial period for tan is pi. So now your period would be pi divided by your B value. Because if B was 3, it would be a horizontal compression by 1/3. That's like dividing by 3. And rearranging this, your B value would be pi divided by your period. Now, these formulas aren't on your formula sheet. A lot of people, some people memorize it just because it's easy. Some people just think about horizontal stretches and compressions and it just makes sense to them, and then they don't need to think about the formula. But these is a very helpful tool to be able to figure out what your B value is or what your period is, depending on if you have an equation or if you have a graph.